This is number 8 on the practice exam. 500 grams of water is heated, and it says calculate the heat required to raise the temperature from 15 to 85. The specific heat capacity is. So Q equals M times C times delta T. So the mass is 500 grams. The specific heat capacity is 4.184 joules per gram degrees Celsius. And then the change in temperature is from 85 to 15. So it's always temperature final minus temperature initial, which is 70 degrees Celsius. You can see the Celsius cancels with the Celsius, the grams with the grams, and we end up with joules. And if you run that through your calculator, you get 146,440 joules are the amount of energy needed to do that. That's letter A. Letter B says calculate the mass of methane required to heat the water. So methane is a gas that is burned in oxygen in what's called a combustion reaction, and of course you make CO2 and H2O, and the enthalpy for this reaction that they tell us is negative 890.3 kilojoules per mole, and that means we have this much energy for every 1 mole of methane that's burned. Now you don't have to actually write the equation, it just helps illustrate that for every one of these, there's this much energy, and that's your link from energy to amount of stuff. Energy to amount of stuff right here. Now, the amount of stuff they want to know, obviously, is in mass, but if you can get it into moles, then you can convert it to grams. So let's start with the 146.440 kilojoules right here that was needed to heat up that 500 grams. For every 1 mole of CH4, there were 890.3 kilojoules of energy that were needed to do that. Once I get the kilojoules to cancel the kilojoules, then I can convert from moles to grams of CH4 by using the periodic table. And CH4, when you add it up on the periodic table, it adds up to 16 because carbon's 12, each hydrogen is 1. And then when you divide these two, multiply by 16, you end up with 2.638 grams of CH4 that are needed to produce that amount of energy.